Welcome to Maths with EJD. Still talking about generating functions. Our focus is now on sum of independent random variables. Okay, if x1 and x2 are independent random variables, the probability generating function of the sum s equals x1 plus x2 is gs of s, g sub s of s is equal to g x1 of s multiplied by g x2 of s. Okay, so that's the basic statement talking about the sum of independent random variables. So based on that, we can take an example. So x1, let x1 and x2 both follow Bernoulli distributions. From a previous video, we already saw that a Bernoulli distribution is a distribution with one trial, and there are two possibilities. Probability can be 0 or 1, basically. So let x1 and x2 both follow Bernoulli distributions with probabilities P1 equals 0.4 and P2 equals 0.6, respectively. Okay, so the task is to find the probability generating function of the sum of the random variables s, which is equal to x1 plus x2. So with that, we move on to the solution. Okay, so the PGF, the PGF of x1 is such that we have gx1 of s, and that is because, of course, from what we did previously, right? We already know that that should be of the sum of x, say let's say x1 from 0 to infinity of the probability x and s raised to power x, basically. So in that case, it means we have probability 0. When x1 is 0, probability 0, s raised to power 0, plus probability 1, s raised to power 1. In this case now, the probability we have, so this P1 now is our probability 1, and P2 is our probability. So it will be this will be the probability. I'm trying to, so this will be actually the probability 1 for the second situation. So in the first instance, right? Um, I think let me try to do the explanation properly. So in this case, our focus is on the first random variable. So this is more like the probability that x1 is equal to 1, more like it. And then this is the probability that x1 is equal to 0. So as far as x1 is concerned, okay? So when we come for the other one, I'll also explain that. So it means that here we have, uh, in that case, this is P1 for the first one, and this is P0 for the first one, you know, because the focus is on one. So P0 for the first one is actually 0.6 s raised to power 0, and P1 is 0.4 s raised to power 1. So that is 0.6 plus 0.4 s. So in essence, we are saying that the probability generating function of the first variable is actually 0.4 s plus 0.6. So we have that. So next, the PGF, the PGF of the second variable of x2 now would be gx2 of s. And that is, of course, summation from x2 equals 0 to infinity of probability x s raised to power x. Now, just like what we did before, right? For the second situation now, this variable for this for variable one is actually maybe I should actually write it out here now. So the probability P2 actually is the same thing as probability that x1, probability that x2 is equal to 1, okay? And that is 0.6, yeah, that is 0.6. And then P, um, and that, of course, that corresponds with what would actually be, since x2, since x2 is in focus here, that would be, or better still, let me start from from the zero side of things. So if I come back here, what I explained the other time here is actually this, that probability that P1 is actually probability, uh, it is the probability that X1 is equal to 1, okay? And that is 0.4. Then the P2 we had is actually probability that X1 is equal to 0, and that is 0.6. So as far as this is concerned now, so this is actually P, this is actually P of, this is P, okay, well, this tallies with P1 in this case, and this tallies with P0 in this particular situation, right? And then when we go for the second one now, so the probability, uh, the P1, the original P1 we have, right? The P1 we have, now that the focus is on the second random variable, right? So the probability P1 that we had there, which is actually 0.4, is actually the probability now that x2, probability that x2 is equal to 0. And then, of course, that would be like the P naught in this situation. And then that P2 that we had, that we have, which is 0.6, is probability that x2 is actually equal to 1. And that will correspond to our P1 in this specific situation. So if we go up and continue with this, it means we have P naught S naught plus P1 S1. Now, because the focus now is on the focus is on P2, so we already know P naught is what corresponds with the variable that is not under consideration. So this will be 0.4 S raised by 0 plus P1, that is 0.6 S. So that this is 0.6 S plus 0.4, basically. So for the second variable now, so we can just say, therefore, g of x2 of s is equal to 0.6 s plus 0.4. Now, what we are interested in is actually the sum of independent random variables, which is ultimately this. So far we have got these ones in their different respects. So we can then continue to say that since x1 and x2 are independent, since they are independent, since they are independent, the PGF, probability generating function of S, is the product, is the product of the two PGFs, of the two PGFs. So that means that we have GSS equals GX1 of S multiplied by GX2 of S. So we have this. Then we can continue to say now that GSS is equal to GXS, that's the first one, GX1 of S rather, that's 0.4S, 0.4S plus 0.6 multiplied by 0.6S plus 0.4. So we can expand this now and we get the result. So if we expand this, we have 0.4s times 0.6x, that is 0.24s squared. Then so we can do this. Then the other part is we can add this together. That is 0.4s times 0.4. That is okay. I mean, let's just do it like a layman, so to speak. So 0.4s times this is 0.24s squared. This is 0.4s times 0.4. That is 16, right? That's one. No, that should be 0.16. 0.16s. And 0.6 times 0.6, that is 0.36s. And 0.6 times 0.4, that should be 0.24. So if we tidy all of this up, we have 0.24 s squared, then 0.16 plus 0.36, that should be 0. That should be 0. That's 0.52. Yep. Or 0.4 times 0. That's 0.16. 0.6 times 0.6, that is 0.36. Yep. Yes. That's 0.36. So 0.16 times 0 plus 0.36 should be 0.52s. 16 plus 36 is 52. Then plus 0.24. And that's what we need to get. So we can conclude now and say, therefore, the PGF of X1, the PGF of S equals X1 plus X2 is GS of S, which is equal to 0.24s squared, 0.24s squared plus 0.52s plus 0.24. And that's how that goes, right? 4 times 6, 24, yeah. 4 times 4, 16. Then 6 times 6, 36. So 0.16, 0.36. 6 times 4, 24, yeah. So that's how it is. So watch out for the next video, which is about advanced applications and inversion of probability generating functions. So if you have not subscribed, be sure to do that right away. Hit the notification bell also so you can get alerted each time a new video is released. Then comment. Let me know how helpful this video is for you. And also comment, let me know if you have a topic you like me to teach or a problem to solve, and then like and share so that more people can have access to this great content. Like, come your way again. Keep doing math right. Bye.